Hello, my name is Tanja and I'm an application scientist at Bruker BioAFM. Today I'd like to introduce smart mapping, a mode that provides enhanced nanomechanical mapping capabilities. Smart mapping allows the labor-free investigation of the biomechanical properties of living cells, tissues and biomaterials under near-physiological conditions. Combined with a direct overlay optical calibration tool, smart mapping enables the precise, easy and flexible selection of regions of interest and automated testing of large, uneven samples such as tissue biopsies. Using the new scan region selection tools, multiple scan regions can be chosen with user-defined shapes such as lines, rectangles or even freehand drawn shapes. Any shape can be sketched directly over the optical image, the resolution adjusted and modified with the eraser tool. Once the experiment parameters have been set, the software automatically acquires multiple force maps, corrects drift, and compensates for differences in sample height, ensuring high-quality, reproducible measurements and an automated workflow. Together with powerful batch analysis tools, using the most common physical models, the smart mapping feature consistently delivers statistically relevant data. By combining nanomechanical mapping with fluorescence microscopy, mechanical parameters can be correlated with optical information. Smart mapping provides the versatile selection of user-defined mapping areas, automated measurements and batch processing for maximized throughput and higher productivity, label-free nanomechanical mapping of large sample areas, and correlative multiparametric analysis of living cells, tissues and biomaterials. Bruker, the pioneers in quantitative biological imaging, now brings you the next generation of advanced mapping, smart mapping.